Hello everyone, welcome to my channel. If you haven't, please watch my introduction video. Today we are going to be learning about ListStack. So without further ado, let's get right into the video. When you are learning about data structures and algorithms, ListStack is one that we cannot miss. On today's video, I'll explain what ListStack is and what it can do. I'll start by introducing the ListStack concept, then I'll explain there are three main operations: push, pop, and peek. After that, we'll look into the structure of a list stack, followed by the code implementation. Finally, I'll discuss the advantages and disadvantages of list stack. So let's get started. So, before understanding a list stack, we need to understand what a stack is. A stack is a linear data structure that follows the LIFO principle, which means last in, first out. The last element added to the stack is the first element removed. This stack is simply a stack implemented using a linked list. Instead of storing elements in an array, the elements are stored in nodes connected using pointers. Because of this, the stack can grow or shrink dynamically during program execution. So, what is a list stack? A list stack is made using linked list nodes. Each node contains two parts, the data and a pointer to the next node. One major advantage is dynamic memory allocation. Unlike arrays, we do not need to define a fixed size at the beginning. Memory is only used when new elements are added. Since it's follows the LIFO principle, the most recently added item will always be on the top. There are three main operations in list stack. The first operation is push, which adds an element to the top of the stack. The second one is pop, which removes the top element. The third one is peek, which displays the top element without removing it. These operations make stack data structures very useful in many applications, such as undo systems, function calls, and expression evaluation. I will explain them more thoroughly in these next slides. So, the pop operation. The pop operation removes the first top element from the stack. First, we check whether the stack is empty. If the stack is empty, we cannot remove anything. If the, if the stack is not empty, we temporarily store the current top node. Then we move the top pointer to the next node. Finally, we delete the old top node. This operation is efficient because it only works with the top element. The next is the push operation. The push operation adds a new element to the top of the stack. First, a new node is created. Then, the value is stored inside that node. After that, the new node points to the current top node. Finally, the top pointer is updated to the new node. This makes the newly added element the new top of the stack. The next one is the peek operation. The peek operation allows us to remove the top element without removing it from the stack. First, we check whether the stack is empty. If it is not empty, we simply display the value stored at the top node. This operation is useful when we only need to see the current top element while keeping the stack unchanged. So now I'm going to explain about the structure of the list stack. The structure of a list stack is based on linked nodes. Each node stores data and also contains a pointer to the next node. The stack uses a special pointer called the top pointer to keep track of the first node. Whenever a new element is pushed, it becomes the new top node. Whenever an element is popped, the top pointer moves to the next node. This link structure allows the stack to expand and shrink dynamically. For the code implementation part, I'm going to explain ListStack using Java. As we know, a ListStack is a stack data structure that uses a linked list instead of an array. It follows the LIFO principle, which means last in, first out. So, the last element added is the first one removed. Here, I have my Java program, which contains three main parts: a node class, a ListStack class, and the main method where I test everything. So, this is the node class. Each node stores two things: the data, which is the value, and the pointer called next, which connects to the next node in the stack. This is what allows the stack to grow dynamically. And the next is the ListStack. In the ListStack class, we have a variable called top. Top always points to the first element of the stack. If the stack is empty, the top is null. In the ListStack class, I have all the functions written. The first one is push, where we enter the new variable. And the next one is pop, where we delete the last variable. And the next one is peek, where we can just display the last variable entered without deleting it. And the next one is display, where I can display all the elements in the stack. Now, the push operation adds an element to the stack. First, a new node is created. Then it points to the current top. Finally, top is updated to the new node. So every new element becomes the new top. Now I'm going to push some values into the stack. First, I'm going to push 10. The next, I'm going to push 20. As you can see. And lastly, I'm going to push 30. And to confirm this, I'm going to display the stack. So I'm going to write stack dot display, and don't forget the brackets and the semicolon. Now I'm going to run this. As you can see, we got the result 30, 20, 10. Since we lastly at the 30 value, it's on the top because this uses the LIFO principle, last in first out principle. The next one is the pop operation. Here we can see the pop operation. Now the pop operation removes the top element from the stack. Here I'm going to my main class again, and I'm going to pop 30 since we had it last. So I'm gonna write stack dot pop brackets and a semicolon, and I'm going to run this file again. As you can see, the 30 is removed. Now the 20 becomes the new top. And next is the peek operation. The peek operation simply shows the top element without removing it. So I'm going here again, and then I'm going to remove the display operation, and I'm going to write peek. And now I'm going to run it again. Now the top element it says 20, and because this is correct, since we add the 10 first and the 20 second and the 30 third. Now because the 30 is deleted, the 20 becomes the new top. So in summary, ListStack is a dynamic stack implementation using linked lists. It allows efficient push and pop operations in constant time, making it very useful memory efficient applications. So now for the advantages and disadvantages of ListStack. Like every other data structure, the ListStack also has both advantages and disadvantages. Some advantages are dynamic size allocation, efficient push and pop operations, no fixed memory limit, and memory is only used when needed. However, there are also disadvantages, like extra memory is needed for pointers, it is more complex than array implementation, access can be slower because of pointer traversal, and elements cannot be directly accessed using an index. So, choosing between an array stack and a list stack depends on the requirements of the application. And thank you for watching my video, and please stay tuned for other videos.